Hello, dear student. Myself Dr. Surekha Jaiswal, Head Department of Physics, Moreshwar College, Bhokardan, District Jalna. Today we will see course code 302, paper number 16, semester 5, Electromagnetic Wave, chapter number 3. Now, here contents are Introduction to Electromagnetic Wave, origin of electromagnetic wave, and third point, that is characteristic of electromagnetic waves and electromagnetic wave equation in conducting medium. Electromagnetic wave equation. Now see electromagnetic waves. In the preceding chapter we have discussed Maxwell equation in static fields and time varying fields. Maxwell equation was the prediction of existence of electromagnetic wave, and Maxwell proved that an electromagnetic disturbance obtained by a charged body would travel out as electromagnetic wave with velocity of light in free space. The goal of this chapter is to gain an understanding of basic principle of wave propagation. About 150 years ago, James Clerk Maxwell, an English scientist, developed a scientific theory to explain electromagnetic wave. He noticed that electrical field and magnetical field can couple together to form electromagnetic waves. German scientist Heinrich Hertz showed that when an electric current bouncing back and forth in a wire could be the source of electromagnetic waves. Electric spark creates such back and forth current when they jumps across a gap. Hertz in 1886 used such spark to send a radio signal across his lab. Later, the Italian Marconi, with more sensitive detectors, extended the range of radio reception. Waves are of two types, namely transfer and longitudinal wave. In the former, the vibrations are perpendicular to the direction of wave propagation, and in latter, the vibrations are parallel to the direction of wave propagation. Alternating electric and magnetic fields are created by accelerated charges, and they propagate out from these charges at the speed of light in the form of waves called as electromagnetic wave or radiation. The environment of the earth is widely affected by various types of radiation such as power waves, radio waves, microwaves, infrared, visible, ultraviolet, X-rays and gamma rays. Electromagnetic wave exhibit transfer nature with its electric and magnetic field components being mutually perpendicular to each other and perpendicular to direction of propagation. The behavior of waves depends upon its own characteristic of medium. Now, origin of electromagnetic wave. The field generated by the moving charges can be diverse from source and travel through the medium in the form of waves called an electromagnetic wave. The electromagnetic wave consists of both electric and magnetic field perpendicular to each other and also perpendicular to the direction of propagation. The characteristic of electromagnetic wave depends upon medium properties such as linear, non-linear, isotropic or anisotropic, homogeneous or inhomogeneous, conducting or non-conducting, air or vacuum, etc. In a vacuum, electromagnetic wave always travel at the same speed, the speed of light. Electromagnetic wave propagate outward from the source just like regular transfer wave. The best source of electromagnetic wave is an accelerated charge because when a charged particle undergoes acceleration, it radiates electromagnetic wave. Imagine two charges at rest in each other's vicinity immerse in each other's electric force field. If one charge suddenly begins to oscillate up and down, the second charge experiences the change in the field of the first charge. After some very small finite times elapses, the oscillating charge was accelerated and the moving charge's electric field changed as do their magnetic fields. These changing electric and magnetic fields generate each other through Faraday's law of induction and Ampere's law. The changing field dissociates from the oscillating charge and propagates out into a space at the speed of light in the form of electromagnetic waves. Two metal rods connected to an alternating current generator causes the chain to oscillate, and such oscillating charges create currents in rod which in turn produce magnetic field as well as and finally in result produce electromagnetic wave. The magnitude of field at any instant depends upon the amount of charge on the rod at that instant. When electric or magnetic field varies with time, the other field is introduced in space around it. The net effect is that electromagnetic disturbance is generated due to changing electric and magnetic field. The disturbance propagates in the form of electromagnetic wave. Let us consider an electrical circuit containing a parallel plate conductors as shown in figure. See in figure. In the absence of condenser, if key is closed, an electric current is set up in the circuit called a conducting current. By using Ohm's law, J equal to sigma E. A magnetic field is produced around the conductor wire due to this conduction current. If key is open, the circuit is discontinuous and current becomes zero. So, see in figure, if key is here open, then what happens? The circuit is discontinuous and here current becomes zero, and but if condenser is inserted and by pressing and releasing the key, the condenser is charged and discharged. This circuit is discontinuous for a direct current, a medium between the plates due to the change in electric field between the plates, and then resulting current is called displacement current. Examples: the electromagnetic wave generators are a electric spark produced in the air gap between two electrodes of a spark plug of motorcycle. Second, a spark produced between oppositely charged clouds generate electromagnetic wave or disturbance received in receiver in rainy days. And third one is in LCRs resonating circuit, electromagnetic waves of different frequencies are produced for audio and TV communication. Now next, that is a characteristic of electromagnetic wave. First characteristic, electromagnetic waves differ in wavelength or frequency, and they can be grouped into different types of depending on the range of wavelength or frequency. Second, the source that produce them and method of their detection are different, but they have the following common characteristics. First, electromagnetic waves are propagated by oscillating electric and magnetic field, oscillating at right angles to each other. Second characteristic is electromagnetic wave travel with a constant velocity of 3 into 10 raised to 8 meter per second in vacuum, and electromagnetic waves are not deflected by electric or magnetic field. Electromagnetic waves can exhibit phenomenon of reflection and refraction, interference and diffraction. Now, characteristic of electromagnetic wave is electromagnetic waves are transverse in nature. Also, electromagnetic wave may be polarized. And next property, that is electromagnetic wave need to medium for propagation. The energy from the sun is received by earth through electromagnetic waves. The wavelength lambda and the frequency nu of electromagnetic wave is related to C equal to mu lambda, that is equal to omega upon k. The intensity of electromagnetic wave depend upon the intensity of electric field strength. More the strength, more is the intensity. It is measured in volt per meter. Intensity of electromagnetic wave depend upon the intensity of electric field strength. So, if the intensity is more, the intensity of electromagnetic wave is depend on the electric field, and its unit is volt per meter. While propagating through medium, the energy of wave is wasted, and this loss of energy is termed as attenuation. Attenuation occurs due to buildings, trees, hills, etc., which absorb the energy of electromagnetic wave. Next, that is when electromagnetic waves are propagated, the energy of these waves is equally distributed in electric field and magnetic field during propagation. Electric field and magnetic fields are always related each other, and whenever there is an electric field, the magnetic field will also be present over there. Now, electromagnetic wave equation in conducting medium. That is electromagnetic wave equation. First, the wave equation satisfied by electric field vector E and magnetic field vector B can be obtained by using Maxwell equation. Now, to start with, we derive wave equation for free space, and the results can be modified for any other medium. The medium may be homogeneous, for which permittivity epsilon and permeability mu and conductivity C sigma are constant throughout. Permittivity is denoted by epsilon, permeability is denoted by mu, and conductivity is denoted by sigma. It may be isotropic or which permittivity epsilon is scalar, and obviously D and E are in same direction everywhere. Now let us assume that the electric and magnetic field that are present in medium vary with time in an arbitrary manner. The four Maxwell equations satisfied by these fields, that is del dot D equal to rho, del dot B equal to 0, and del cross E equal to minus delta B by delta T, and del cross H equal to J plus delta D by delta T. For free space, we have J equal to 0, rho equal to 0, sigma equal to 0, and mu equal to 1, epsilon equal to 1, mu r equal to 1, and D equal to epsilon 0 E, and B equal to mu 0 into H. Now where epsilon is permittivity, mu is permeability, sigma is conductivity of medium, and suffix 0 stands for free space, while sub R indicate relative quantity. With this substitution for free space, the Maxwell equation becomes del dot E equal to 0, del dot B equal to 0, and del cross E equal to minus delta B by delta T, and del cross B equal to mu 0 epsilon 0 delta E by delta T. Now to obtain the wave equation satisfied by electric field vector E, let us take curl of Maxwell's third equation, that is del cross E equal to minus delta B by delta T. So here, taking the curl of this equation, we get del cross E equal to minus del cross delta B by delta T. Now here del cross E equal to del into del dot E minus del square E equal to, here del dot E equal to 0 minus del square E. So equating this with RHS, we get minus del square E equal to minus del cross delta V by delta T, and equal to minus delta by delta T del cross V equal to minus delta by delta T mu 0 epsilon 0 delta E upon delta T, that is the value of del cross B. So del square E equal to mu 0 epsilon 0 del square E upon del delta square by delta T square E, that is similarly taking curl of Maxwell fourth equation, we get del cross B equal to mu 0 epsilon 0 delta by delta T of del cross E, and LHS can be written as del cross B equal to del into del B minus del square B equal to 0 minus del square B, and therefore we get minus del square B equal to mu 0 epsilon 0 delta by delta T del cross E equal to minus mu 0 epsilon 0 delta by delta T of delta B by delta T, and therefore is equal to mu 0 epsilon 0 d delta square B by dt square and so del square B equal to mu 0 epsilon 0 gamma square B by gamma T square, and the equation becomes del square E equal to mu 0 epsilon 0 into gamma square E upon gamma T square, and therefore del square B equal to mu 0 epsilon 0 gamma square B by gamma T square are identical, indicating that the variation of field vector E and V are similar, but it does not mean the E and V are equal. Comparing this equation with standard waves equation, that is del square x equal to 1 by V square gamma square x by gamma T square, it follows that the field vectors can be propagated as wave in free space, and the velocity of propagation is given by 1 upon V square equal to mu 0 epsilon 0, and putting this value here, mu 0 equal to 4 pi into 10 raised to minus 7 Henry per meter, and epsilon 0 equal to 8.85 into 10 raised to minus 12 Farad per meter, and we get the velocity of propagation of the wave is as, therefore V equal to 1 upon mu 0 under root of mu 0 into epsilon 0, and is equal to 1 upon under root of 4 pi into 10 raised to minus 7 into 8.85 into 10 raised to minus 12, and after simplification velocity equal to 2.99 into 10 raised to 8 meter per second, which is the velocity of light, and thus we can conclude that the electric and magnetic field dissociate from the source, producing it and propagating it in the form of electromagnetic waves through free space with velocity equal to velocity of light as predicted by Maxwell equation. Medium is not essential for propagation of electromagnetic wave. Thank you.